Okay, let's take a look at page 431, number 24. It says 2 tuning forks of frequency 512 and 518 Hertz are sounded at the same time. Describe the resultant sound. Well, the resultant sound will be, loud, going loud and then soft and then loud and then soft. You'll hear what are known as beats. And then it says calculate the beat frequency. It's just F1 minus F2, take the absolute value, you get 6 Hertz. Okay, so you'll hear loud, soft sound 6 times in a second, or 6 Hertz. Number 25 says a 440 Hertz tuning fork is sounded at the same time as the 337, and that's the typo I was telling you about earlier. This is really 437. Can't be 337, it would be 103 apart and you wouldn't hear any beats. Remember, beats have to be 7 or less. How many beats will be heard in 3 seconds? So we can find the beat frequency by just subtracting them and get 3 Hertz. But then the question wants to know, so how many can you hear in 3 seconds? So this is telling us we hear 3 beats in 1 second. So how many should we hear in 3 seconds? We should hear 9 beats, right? 3 times 3. Number 26. A trumpet player sounds a note on her trumpet at the same time as middle C is played on the piano. She hears 10 beats in 2 seconds. So remember, frequency is equal to the number over the time. So 10 beats in 2 seconds. So her beat frequency is going to be 5 Hertz. If the piano's middle C has been tuned to 256, what are the possible frequencies? So it's telling you 256 is the known frequency. And so what are the 2 possible frequencies of the trumpet player? Has to be 5 above or 5 below. So 251 or 261. Okay? Number 27. The string on an Ediftune piano is struck at the same time as a 440 Hertz tuning sound. Okay, so the one we know, F1, is 440 Hertz. The piano tuner hears 12 beats in 4 seconds. So the beat frequency, 12 beats in 4 seconds, or 3 Hertz. So the 2 possibilities right now, with knowing that the tuning fork is 440 and that he's hearing 3 Hertz, the 2 possibilities are 437 and 443. Now you have to read the next part to decide which one's right. Because it says he then slightly increases the tension in the string in order to increase the pitch of the note. Now he hears 14 beats in 4 seconds. So now his beat frequency has gone up. Now he is getting 3.5 Hertz frequency. What was the original frequency of the string on the piano? So these are the 2 possibilities of the string of the piano. And then the piano tuner tightens them. So if it was 437 and you tighten it, it's going to become 438, 439. It's going to get closer to the 440, so that when you played it, you should hear fewer beats than 3, but we didn't. If it was really 443 and he tightened it, it could go up to 444, 445, even 443 and a half, which is moving further away from the 440, which means if it really is the 443 and he tightens it, you should get more beats, and we do. And so the answer to part A of this question is 443 Hertz. Got to do a little logic though. Part B says, is the piano more or less in tune? It's further out of tune, right? It's now 3.5 Hertz away as opposed to the 3 that it was. So he moved it the wrong way. All right. And then you had 6 and 7 on the sheet, which I have somewhere. There it is. So number 6, a tuning fork has a frequency of 400 Hertz. When this tuning fork is hit at the same time as the second one, 12 beats in 2 seconds are heard. Remember, frequency is N over delta T, so 12 beats in 2 seconds, the beat frequency is going to be 6 Hertz. And if the beat frequency is 6 Hertz, then the two possibilities are 394 Hertz and 406 Hertz. And that's what number 6 is asking for. What are the two possible frequencies of the tuning fork? Number 7 says, you now put a piece of gum on the 400 Hertz tuning fork. If you put gum on the 400 Hertz tuning fork on the prong, it's going to slow the vibrations down. It's going to lower the frequency of F1. And when you strike the two of them again, this time you hear 4 beats as opposed to 6. Okay? So when you put gum on the 400, you lower it. And if the second tuning fork really was 394, then it would be getting closer to the 394. If the second, because it's lowered because of the gum. If the second one was really 406 and you put gum on the first one, lowering it, it would be getting further away from the 406. So now you strike the two tuning forks and you hear 4 beats, which means you're getting closer, which means F2 has to be 394 Hertz. Okay, that really is an H. Try that again. All right, so that's where your logic has to kick in there. Hopefully that makes sense. And that was it for your homework. Practice question.